In this video, we're going to talk about contingency tables. Now, we're going to use the idea of Venn diagrams to relate to what is called a contingency table and kind of build from there. So most of us have had some sort of experience with a Venn diagram. This would be a drawn out example. What's here to the left with the cat, dog, and the circles, that's a Venn diagram. And it's a way of kind of putting down the information that we're given and maybe even figure out some of the information that we don't have. So let's read this example and kind of fill out the Venn diagram from this. So 250 households were surveyed and 180 of them said they had a cat, 95 said they had a dog, and 52 said they have a cat and a dog. Fill out the Venn diagram and then the contingency table, which is the table to the right. Okay, so first thing I want to note is when they say 180 have a cat, that doesn't mean they don't have other animals. We just know that they have a cat. Same with the 95 that said they had a dog. That doesn't mean they only had a dog. If it was only a dog, then we'd know. But because it just says they have a dog, that means that it's possible they have other animals too. Maybe they have a fish, a bird, I don't know. But we can't assume any other information. But when they said they have a cat and a dog, that's a piece of information I can label immediately on this. And that is going to go in this little overlapping section of these two circles. So the first circle to the left is representing all the people who have a cat. To the right, all the people that have a dog. And where they overlap, these are people who have both a cat and a dog. And 52 people fall into that category. Now, we were told that 180 people said they had a cat, which means that they could have had a dog. In fact, 52 of the people surveyed did have a cat and a dog. So that 52 is being counted in the 180. So if I subtract 180 minus the 52, that's going to give me 128. And that's how many people have just a cat but no dog. Now, they could have other animals, but we're not interested in that right now. We're just interested in cats and dogs only. Same with the 95. So those 95 people probably took into account the 52 people that have both. So if we subtract that out, we'll get 43. So there are 43 people who just have a dog, no cat. Now, we were also given one other piece of information, and that was that 250 households were surveyed. And if we add 128 and 52 and 43, let me see, that's going to give me, adding that up, 223, which means there's 27 people not accounted for from the 250. So there's 27 people right here that were 250 minus that 223. Okay. So those are where all our numbers are coming from in this diagram. And I'm going to go and erase all my work because I don't really need that there. That was just for you to see. It's okay if you have it there, but yeah, we'll kind of keep it decluttered on my screen. So that's the basic breakdown. Now I'm going to fill that information into this table. And this is a contingency table. It accounts for every possible outcome. So in this first column where it says cat and dog, those are people who have both a cat and a dog. And we know 52 people fall there. In the next column, they have a cat but no dog. Those are 128 people who fall there. Then to total those, the total is going to be people who just have a cat. And we happen to know that's 180 people. Okay, so then people who have no cat, but have a dog, that is 43 people. Who have no dog and no cat, we calculated that to be 27 people. And now here's the first piece of information we don't have calculated. We don't know the total of people who don't have a cat. Now, if I just total 43 and 27, that comes out to 70. But that makes sense because if 180 people said they had a cat out of 250, that leaves 70 people left over who don't have a cat at all. Okay, so the column then, the total for the first column of dog, people who own a dog, we know that happens to be 95. But if we add together 52 and 43, it does add up to 95. Now, people who don't have a dog, again, we could figure that out. by adding 128 and 27, and that comes out to 155. But that's also what would happen if we subtracted 95 from the total of 250. And 250 is what I'm going to put here because that's the total of both the rows and the columns. They total up to 250. So this gives me like every possible scenario. And we use contingency tables when we start calculating probabilities. So let's go ahead and look at some types of probabilities and kind of discuss them and how they relate a lot to contingency tables. So the first type of probability we're going to look at is called marginal. And a marginal probability is really referring to the total row or column. So it refers to where it literally says total, the last column and the last row, the total column or row, doesn't matter which one. Oops, that's not how you spell column. There's an N or row. That's the where we're going to be getting our probability information from. All right, so let's look at this. And here I'm going to zoom out a bit just so I can look at that. So the probability of a cat. Well, based on my table there are 180 people who just have a cat out of 250 total. And I can divide that on the calculator. And I'm going to get 0.72, which is 72% if I want to write it as a percent. I'm not going to. I'm going to go ahead and leave it in decimal form. I don't know how the homework wants it. It'll indicate whether it's wants decimal or percent or even fraction. But yeah, we're going to bounce back and forth. But for right now, I'm going to pretty much stick with decimal just because 0.72 in math talk is the exact same thing as saying 72%. Okay, so now and probabilities are exactly as you would kind of think situations into one scenario. So find the probability that a randomly chosen person from the study has a cat and a dog. So when I look at the table, well, I happen to know that people with cat and a dog, there's 52. And that means that this is going to be 52 out of 250. Which when I plug in the calculator comes out to 0.0 or 20.8% if you want to write it as a percent. So an and probability, you're typically looking at one cell somewhere kind of in the middle of the contingency table. Now, or is where it gets kind of tricky, okay? With an or probability, we have to worry about shared information, okay? So we have to worry about overlap. You have to pay attention to where we have overlapping information. So let me show you an example. We want to look at the probability of somebody has a cat or has no dog. So these are two different scenarios. We want to find the probability that somebody has a cat or they potentially just don't have a dog. All right. Now there are people who don't have a dog, but also don't have a cat. So this is going to account for those people as well in this probability. We're going to find they either have a cat or just no dog at all. Those are the people we're interested in. So what ends up happening is we end up looking for what's the probability of somebody wanting a cat, having a cat, and then looking at the probability of them having no dog. And then we're going to have to take into account one of the things. So let's start with that. So probability they have a cat, we actually already know that that's 180 out of 250. Here, I'm going to zoom out a little so I don't have to keep scrolling back and forth. A little bit more. All right, 180 out of 250. And then the probability out of 250. Okay. But here's the problem. The 180 out of 250, that came from looking at this row, right? People in that row. And the 155 out of 250, that came from people in this column. And what we have here is one number, this group of people that got counted twice. They got counted in the cat group, but they also got counted in the no dog group, which means they got double counted. So I have to subtract off that group of people. So I'm going to zoom in a little here to do that. So I'm going to subtract out the people who have a cat and no dog. They're the people in this category. So that's this number 128. They have a cat, but they also have no dog. So that 128 got counted twice. And I'm going to add those together and subtract the 128. So 180 plus 155 minus 128 comes out to 207 out of 250, which is a decimal is 0.828. And I'll leave it at that. So this kind of an or probability, we sometimes have to worry that if something gets double counted, we have to account for that. We have to deal with that people when they have something in common. Okay, a conditional probability is when we limit the total that we're looking at. We limit the total we are using. So you'll notice up until this point, we've been dividing by 250 every single time because we've been talking about the whole surveyed group. But now I'm going to change that. So given that a person from the study has a dog, what is the chance that they will have a cat? So I'm no longer looking at everybody in the study. I'm only looking at the people who have a dog. Oops, I thought I hit the highlighting button and I didn't. Highlight, who has a dog. So I only want the people who have a dog, which means when I come back up here, erase my highlights, people who have a dog. So that's this column right here. So there are 95 people who have a dog, and that's the only group I'm looking at. I'm only looking at those 95 people. So I'm only working out of 95 now, not 250. And we want to know the probability that they have a cat. So of those 95 people, 52 of them have a cat. Oops. Which when I divide comes out to, oh, I just realized I wrote the wrong number up here on this one. Oh, wait, no, I didn't. I didn't write the number at all. There we go. Okay, so let me grab my calculator. 52 divided by 95 comes out to 0.547. And I have been including 3 decimals just because in general, if it goes beyond 2 decimals, I tend to just include 1. But hopefully the problems will indicate where they want you to round to. Okay, so let's try it again. This time we're given the contingency table, and we're going to use what we just did to kind of understand the probabilities. So we're going to label whether or not we're doing a marginal, an and probability, an or probability, or a conditional probability. And then we're going to find the probability of each. So this information, we're going to figure out how many people identify as female. So looking at the female, that's the row. That means I'm going to be looking at 45 out of 75 total. That's the bottom total. So 45 out of 75 comes out to 0.6. Or if you want to write it as a percent, 60%. Now, in terms of the labels, because we looked at far right columns where we're the marginal probabilities. All right, let's try the next one. What is the probability that someone buses to OCCC? So now we're looking at columns this time. So we're looking at the bus column, and I see that 19 people take the bus out of 75 total, which would be 0.253. And just like last time, because I got my information from the total, the bottom row, that means that this information is, or I'm sorry, this type of probability is what we call marginal. Now, I'm not super concerned that you know that phrase, the marginal versus and or conditional. I'm just kind of wanting you to be aware of that information in case you move into like a statistics class that would use that kind of terminology. Okay, let's look at next. So identify as non-binary or genderqueer and drives themselves to OCCC. So that actually gives away exactly the type of probability we're doing. This is an and probability. And for this, we'd be looking at people who are both identify as non-binary or genderqueer and drive themselves. So up here, that would be this 2 right here. Those people, oops, it kind of upset my table. Those are the people who would qualify as both non-binary and genderqueer or drives themselves. So 2 out of 75, which is 0.027. And it's an and probability. I don't know why I put and so far to the right, but whatever. It's giving myself space to work. Okay, so for this one, they identify as male or walk to OCCC. So or here gives away that we're working with an or probability. Here, I'll just put it up here. And I'll move the and up because it's just bothering me that it's sitting out there by itself. And so now we're looking at male or OCCC. So people who are male, that would be this row right here. That whole row are people who are male. So there's 25 total who identify male. Okay. And here, I'm going to put M underneath that to represent that those are the people who are male. Or walk. So for walking, that would be this category right here, that column. And it looks like there's only 4 out of 75 who walk. But now I have to make sure, because it's an or, I don't know why I put a bar there. I have to make sure that that there is no overlap here. I have to worry about overlap with or. So, oops, I'm going to put plus in between those two. I might have to subtract out something they may have in common. So is there a double counting? And the answer is yes. This one right here is getting counted in both the 25 total and the 4 total from people who are walking. So I have to subtract that overlap of 1, which gives me, let's see, 25 plus 4 minus 1 is 28 out of 25, which is 0.373. And or is probably the real complicated one out of these, because we have to deal with that overlap here, this group where they're both male and they walk. Wow, that's so badly written there. That's supposed to be an and symbol, and it looks like a weird, just squished up, who knows what. So that's supposed to be an and, male and they walk. So there's one person who's both identifies as male and walks. Okay, so now back here again. Given a student from the survey identifies as female, okay, so that means they're giving us a condition. So this would be conditional. Oops, that's not how you spell conditional. Conditional. In this case, the condition is that they are female. So that means I'm only looking at the females. And that means I'll be only looking at this first row. So my new total is now out of 45. Here, I'll just kind of do it over here to the right. And we want to know what's the probability that they take the bus. So out of those 45, there are 12 who take the bus. And when I divide 12 by 45, I get 0.267. Now this, even though it's written a little differently, is still a conditional. If a student drives themselves to campus, what is the probability they identify as non-binary or genderqueer? So again, they're limiting us to just the people who drive themselves. So again, it's a conditional. The condition is they're driving themselves. So we're going to limit ourselves to the row of people who are, I'm sorry, the column of people who are driving themselves. So this column right here. So that 43 people, that's what we're limiting ourselves to. And we want to know of those 43 who identify as non-binary or genderqueer, and that would be 2. Which, when I divide, is 0.047.